Alright, in this circuit, we are given this circuit diagram of a few resistors and a BJT, and we are asked to find the value I, the current flowing through this resistor, and V, the voltage at this node. We are given that B, the amplification factor, is exactly 100. So, to start off, we start off with the KCL true facts that ICC, the current flowing in, is equal to IB plus IC, which is the current flowing into the base plus the current flowing into the collector node. Second, we go for this equation, IC plus IB equals IE. So IC, the current going in here, and the current going in here is equal to IE, the current going out, which is also another name for the value that we're looking for. And then we go for the third equation, which is the KVL law. Yes. So I'm not reading it. It's this thing, and this is following the voltage sum from here all the way down here, this path. It must sum to 0. And then we go for the KVL law for base emitter node, which is the path going all the way across here. That must also sum to 0. That is this equation. I'm not reading it. And then the last law we invoke is KVL for the transistor. So VBC is equal to VBE minus VCE. Okay, now we start off with assumptions, huh? So the assumption 1, assume that IB is equal to 0. This means that it is in cutoff mode. And if IB is equal to 0, then we go up to here, this equation, which describes how BJTs amplify. If IB equals to 0, then IC is equal to 0, which means it is off and no current is flowing through. And then IE is equal to 0, of course. So then we go back and substitute that value into our KVL BC equation. And we end up with 10 volts is equal to stuff that turns into 0, plus stuff that turns into 0, plus VBE, plus stuff that turns into 0, minus 10 volts. Volts. And then, therefore, VBE is equal to plus 20 volts. But this is much larger than what we expect VBE to equal to, which is around 0.7 volts. Therefore, assumption is incorrect. This is not in cutoff mode, it is in active mode.
So now we run the calculations under the assumption that is in active mode for the BJT. And this assumption is that VBE is equal to 0.7 volts, which is VD naught, and that I sub C is equal to the amplification factor of 100 times I sub B, which is 100 IB. Now, using these conditions, we perform similar calculations when we were performing our assumptions under the cutoff. However, now we do it with these values substituted instead. And so after running through various algebra substitutions as seen here, we end up with a value for the current through the base, IB, is equal to 9.507 microamps. This turns out to be the correct value of I sub B. So using this true correct value, what we do is we solve for VCE, which is going to be what the factor that proves whether our assumption of whether it's in active mode is correct or not. So after doing this calculation, we get that the voltage of VCE is 0.795 volts, which is greater than or equal to VD naught of 0.7, which proves our assumption that this is indeed in active mode. So then, now that we have the true value of VCE and IB, we substitute this into equation 5, and we get that VBC is equal to 0.095. So now that we have these variables solved for, we perform further substitutions using these values that we just currently solved for, and we solve for I sub C, which is this value right here in amps. And since now that we know IB and IC, we can solve for IE, which turns out to be this, which also turns out to be the current value which we wanted originally. Then what we can do is, now that we have that, we have our ICC value, which we got from forming our IB plus IC together. So then we can form a simple KVL using the VCC value and the ICC voltage drop across the resistor, which gives us the value of -4.545 volts, which makes perfect sense.